All right, I'm posting the results before the test because it is kind of boring watching me go through this. In any case, on the top here, you got the amp draw is the largest value I've seen when I switched over to the 10 amp setting. The first two cells are this type here, and it seems like the steel wool did a little bit better, and not much. But the second one is the galvanized is kind of on its own because when I got the BBs, they were galvanized, they were coated. So before I stripped them with acid to use for a steel BB test, I figured I'd just use them. Anyway, the second set here, or these two with the red dots, they're just a single plate on each side. And they should be kind of the same. But the battery one did a little worse. And the reason why I think it is because this plate there's nothing to it compared to the plates. This one's copper. It looks pretty dirty, but there's hardly no surface area on that one. I think that's why it did so poorly. These two down here is actually just like a steel mesh compared to BBs. And the results are pretty much the same. It kind of makes me want to try like shavings, just hammer some steel shavings together, or even copper shavings, and make a plate out of it and see what that does. But anyway, I'm going to try and hold this still so you can freeze the video and take a look at the numbers. All right, I'm going to do a quick capacity test, checking 4 different cells. One's going to be the copper with the steel wool, one's going to be the copper with the straight plates, and then I'm going to use galvanized BBs with a galvanized piece of steel here. Copper's going in both in this cell, and the other one I'm going to run is a piece of steel with steel wool crammed into it, all using potash as my electrolyte. And what the copper probe is going to go in, the positive, is this is from a battery, a sleeve that I snaged, cut down, and none of this is put together yet, of course, so we'll do it as we go, and we're going to record the charge voltage, the amp draw, and what it settles down to after 2 minutes. And the very first one we'll do is the steel wool with the copper plates. Alright, this is the copper and steel wool. It's a repeat on this cell, but we're going to take some better numbers this time for comparison. Alright, it charged up better this time. Disconnecting power. Alright, what we're going to do, put the amp draw, and we're going to log the date of that. Well, it didn't do as good this time. Highest I saw was 2 amps. We'll see what it settles at. Alright, I'm timing these, and after 2 minutes it was down to 0.47. Alright, this one is copper plates against steel plates. Disconnecting power. It's been charging for a while. Alright. Amp draw. Okay. 2.3. I'm going to time this for 2 minutes. Alright, after 2 minutes it was at 0.37, so the steel wool did just a hair better. Alright, I just finished making the BB cell. This is what it looks like. Galvanized with the BBs. They're galvanized coated with the copper in the sleeve. These cell tests aren't really fair, I guess you could say, but neither is life. Let me give you an example. Here's the plates in a battery. There's a total of 11 of them. It'd be 6 positives, 5 negatives. The plates that I'm testing is this size, and doing a comparison, it's probably maybe a quarter of the size, and then there's only a total of 9 plates that I use. So I guess we'll have to compensate for that when we figure this out. Alright, this has been through a couple cycles. I know it is galvanized, so This one doesn't really count. Anyway, disconnecting the power. All right, let's see what she does. All right. Oh. She doesn't do very good at all. All right, after 2 minutes, she's down to 0.12. All right, this one is a copper plate, a steel plate, and steel wool packed in it. Removing power. All right, I'll come back after 2 minutes. All right, after 2 minutes, she's down to 0.07. All right, to make this a little more fair, I wanted to take the zinc off the BBs, so I soaked them in sulfuric acid, rinsed them, then I put the setup back together with the steel plate, so now it's steel BBs, steel plate with copper in potash. It's been probably about the 5th cycle now, so we'll disconnect her and see what she does. All right. 10 amp setting, 1.3. We'll come back after 2 minutes. All right, here we are after 2 minutes. It's down to, well, 100 milliamps or less. All right, here's just the copper plate and the steel plate. 2.29. Looks like it's just plating. Disconnecting. See if it makes a difference. All right, after 2 minutes, it's down to 0.07. All right, and for this last test, we got copper BBs against a copper plate, which is isolated from the steel BBs against the steel plate. All right, we went through a couple cycles. And let's see what she does when I disconnect her. Alright, she's dropping down. Switch this over real quick. 10 amp draw. Let's see what we get. Alright, I'll come back in 2 minutes. Alright, after 2 minutes, it was 0.53. So a little bit better than 500 milliamps. Okay, this cell is copper, like mesh. All right, a copper plate, steel wool and a steel plate, and it's been charging for a while, and it doesn't want to seem to get over 1.1 volts. Let me disconnect the power. All right. Let's see what she does. All right, I'll come back after 2 minutes. All right, after 2 minutes, it was at 0.49. She's still slowly dropping. All right, for comparison, this is 2 plates out of a battery. It's the positive and negative cut down to approximately the same size. It is in acid. Now it's having a really hard time getting a good connection on these. It's almost like I needed to sand it or something. But anyway, it's been charging for a little bit, so we'll disconnect it and see what this one does. Right. Jeez, that didn't seem right.